Hello, everybody, and welcome to this session on SQL on FHIR use cases and the implementation showcase. So hopefully, this is the middle session of our SQL on FHIR triple header. Hopefully, a lot of you got to listen to Ryan Brush's presentation earlier about the specification. And so what we wanted to do in this session is talk about the specific use cases and the many implementations that we already have for the SQL on FHIR specification and a little bit about where it's going. So I am Arjun Sanuyal. I'm the Director of Product at NCQA, and I have the privilege of helping organize the SQL on FHIR and FHIR Analytics working group, where all of these gentlemen participate and a number of you in the community. And you know, it's been a terrific experience for me, and it's a very warm and welcoming community, you know, I think in the best spirit of HL7. So I'm going to give a very brief 2-minute introduction to what SQL on FHIR is about, and then hand it over to Alex, John, and Nikolai here, and Bashir, who's on Zoom, to really dig into the different use cases that people are seeing for SQL on FHIR even at this early stage. So if I were to boil down SQL on FHIR into one sentence, what is it? It is, they are portable tabular projections of FHIR resources. So we're talking about a specification that defines, they'll go into it in a lot more detail, the artifacts needed to create portable tabular projections of FHIR resources, and the implementations on the specific data system, and we call those view runners. So like I mentioned, this session is about the use cases that folks are targeting for SQL on FHIR, and you know, an expanding set, and then the implementations. Like I mentioned, we have already for SQL on FHIR, for the specification, 6 independent implementations. The first being a reference implementation written in JavaScript, the second being AidBox, which Nikolai will discuss, the third being Pathling, which John will discuss, the fourth being Google's Open Health Stack, which Bashir will discuss, and the last but not least, NCQA's implementation in C++ for Alex. But I did want to mention the one that is not represented here, which is Graham Greaves' implementation in Java. And that is currently being baked into the IG publishing workflow. So if you're starting to use the current versions of IG Publisher, you have the capacity to use SQL on FHIR. And that's a pretty distinct use case, which we don't talk about here, but a really interesting and powerful one. So SQL on FHIR, you know, you may have it already, and you may not even know it. That use case has to do with taking FHIR data, FHIR examples in IGs, processing them with SQL on FHIR and the artifacts we'll talk about, and then presenting it back in a nice form, a templated form in an IG. So, you know, really there's a broad set of use cases. It's a set of tools to think about FHIR data in tabular forms across a vast array of systems. So that's super exciting. And like I just mentioned, we have 4 of those implementations represented in this session. But next up, our last session right after this one is Nikolai doing a Let's Build session using the JavaScript reference implementation. So you can get your hands dirty with SQL on FHIR in your web browser. So little ad for that. So where is SQL on FHIR going? We plan the first milestone release of SQL on FHIR end of summerish. So sorry to can't be more specific about that, but we're very, very close. You know, we don't think those timelines will slip. So let's build together. You know, we have a really great, warm, welcoming group. We're all in different countries and continents, and so analytics on FHIR is where we hang out. We have a weekly Zoom meeting. It's Tuesdays, 3 p.m. Eastern time, so please come and join us. They're also recorded, so if you can catch up later. And more specifically, the spec is being finalized for the Milestone 1 release, so please go and check out the spec. We would love to get fresh eyes on the spec. Like, we've been looking at this for some time, but we need new eyes on the spec to help us understand what parts are hard to understand, what's missing. So we would, that's my ask of all of you, get your eyes on the spec. And then, of course, the code behind the reference engine. So yeah, I'm just super excited to have this session and have all of you get to learn more about SQL on FHIR. So join the movement. Please hold your questions until the end. We have a bunch of speakers, so we'll definitely have some time at the end for questions, so just request to do that. And then with that, I'm going to hand it over to Bashir from Google. And hopefully he's...
Hello, can you guys hear me?
Yes, we can.
Oh, excellent. Okay, cool. Thanks, Arjun. And sorry, everyone, that I can't be there in person. So on Sunday, I was denied entry to US after over 10 years of traveling as a Canadian citizen, including 6 months ago, and I exactly don't know why. But anyway, thanks for the organizers to make it possible to present remotely. So I'm going to talk through our implementation of the spec, and specifically how we use view definition. So if you go to the next slide, Arjun, please. Yeah, this one. Okay, so just a reminder of the work that we are doing. So Open Health Stack is a bunch of components that is basically the goal is basically to make it easier to deploy digital healthcare systems in low resource environments. So everything that we do is open source, and everything happens on GitHub basically. And the analytics component, like the FHIR data pipes, is one of those components, which actually last year in FHIR DevDays, which I actually could be present in person, I presented one of the sessions, and I have put the links to that slides. And this actually diagram is actually from that presentation. So I mentioned last year where this view definition idea was in earlier stages of development, but in general, our view was that because we want, eventually we want to make the choice of, maybe actually I step back and then quickly tell what the pipelines and what we are doing is. So basically we have some pipelines that take data from a FHIR server, do some transformations to it to make it more efficient to query for analytics queries, for example, converting to Parquet files, and then push it to the data warehouse, basically. So eventually we want to make the choice of the data warehouse an implementation detail, meaning that you can easily switch from, let's say, Parquet and Spark to BigQuery or to Postgres or to other relational database and things like that, depending on the needs that you have, or if you want like a horizontally scalable solution, or no, just like a single node database is fine for you. So eventually we want to make that as an implementation detail. Now the problem is that if you go to the next slide, the problem is that each of these implementations have their own way of creating, flattening data. So when we deal with FHIR data, we have, as you all know, we have a lot of nested and repeated fields. Usually what we want to deal with when we are, downstream data scientists want to work with flat tables. So, so from a long time ago, our view was that defining these flat views can be the interface between like the data engineer and the data scientist, basically. So, the transformation of the data and then creating these flat views can be done by like maybe 1 or 2 people on the team, and then everyone else who want to do just create like reports and things like that, they can work off of the flat views. So that fits very well. The now view definition fits very well this vision basically. So this is again from last year, that each of these systems have their own ways of flattening. Like if you have like data in a Spark SQL has its own dialect, BigQuery has its own dialect, and so on. So what we want to do is that the view definition becomes the standard way of defining these views, defining this interface layer basically. So if we go to the next slide, so basically we are getting there. We are not exactly there, but for one example, we have already switched to using view definition is for relational databases. So last year we didn't have any support for relational databases, and that's what we wanted to add, because our focus was always on horizontally scalable solutions like Spark and Parquet files and distributed file system or BigQuery and things like that. But then many of our partners told us that we don't need that kind of a scalability. We prefer to work with a single node database, for example, and we wanted to add relational database support as well. Now, what we decided to do is that for relational databases, we actually move the view implementation inside the engine, inside the pipelines, and we create materialized views basically. So for other cases, for example, for a Spark SQL, we don't create like materialized views. We create like virtual views basically that show how the flattening is done. But every time that you query that, it's actually a subquery runs. But for the case of relational databases and Postgres, we actually create materialized views. Now, if we go to the next slide, so we still rely on our Parquet implementation. We still rely on our FHIR to Parquet implementation, because then we can use the Parquet files as a cache to recreate views. So if people want to create new views or make changes, it's actually very quick. So the examples that I have here on the right and the bottom are basically the same thing. So on the bottom is the flattening with SQL, with the Spark SQL on top of Parquet files and Spark as the query engine. The one on the right, which you can't read, but there are links that you can later check, is basically the corresponding view definition. Now, if you go to the next slide, so then the idea is that now this is the downstream data scientist that I was talking about. So this is one example from PEPFAR indicators, like for HIV. I think this is for TXPVL, I guess, for people who viral load has been suppressed. So the two queries on the left and the right, actually one is on a Spark, the other one is on Postgres, but you can see that the actual query is almost exactly identical. And that's because they are written against like a flat view buffer. So I guess I am already a little bit over time, so I stop now and I would be happy to answer questions at the end. Thank you.
Hello everyone, my name is Alex Wally and I work at NCQA, and I'll tell you about our use cases for a little bit. Our main one is doing digital quality measurement at scale. So we really use view definitions to slim source data, because when we evaluate measures, we don't need all of the patient data for every measure. So what this allows us to do is optimize how much data we need, slim it down, and reduce the cost for cloud computing purposes. Since we have less data, we spend less time wasted on I/O, which everybody loves, not having to waste time with I/O. And an important thing to note is you don't always have to completely normalize, completely flatten the data. You can still have nested data in Parquet formats. And the second thing we do is we use it for data quality and analytics in FHIR. So we take the FHIR JSON, put it into a Parquet format, and then now we can use existing SQL technologies that we're used to do all these analytics with a familiar programming language and scalability in mind. For our purposes, I wrote a custom C++ FHIR SDK implementation for the view runner from JSON to Parquet, just to try to get that process as quick as possible. And through C++, we're able to leverage SIMD instructions and hardware optimizations that potentially higher level languages aren't able to. And the goal is to have this package that other languages can call into, so you don't have to have your entire code base in C++. Once we have the internal memory representation of the data table, we use Apache Arrow, which is part of Spark, to output as a Parquet file. And then right now we're using DuckDB to load it from Parquet into memory into a Postgres database. Good. John.
Hi, thanks for coming along, everybody. My name's John Grimes. I'm from the Australian eHealth Research Centre, CSIRO, which is Australia's national science agency. I'm the lead on Pathling, which is an open source product that we have for doing FHIR data transformation. It's been around for a few years, but we've only just recently added support for executing SQL on FHIR view definitions. So I'm going to take you through a few of the areas that our implementation focuses upon. First, I'm going to talk about the features that it offers in terms of overall scalability. I'm going to talk about streaming for real-time use cases. Pathling integrates with a FHIR terminology server. I'll explain how that works. I'll also talk about how Pathling integrates with the FHIR bulk data access ecosystem. Pathling is available as a library for multiple different programming languages. And finally, I'm going to talk about our server implementation. Pathling is capable of taking in FHIR data in a few different ways. The first is the FHIR bulk format NDJSON. It can also take in bundles or individual resources in either JSON or XML format. And it can also leverage the streaming capabilities of Spark to read a stream of bundles or resources. We transform FHIR data into a data frame schema that is suitable for running SQL queries over. Then we also implement a FHIR path engine which can translate FHIR path into SQL queries over the schema. Data can also be persisted from this data frame format to optimized formats such as Parquet and Delta, and it can also be exported back out to bulk FHIR. Pathling is built on Apache Spark, which provides a number of advantages when it comes to scaling queries to larger data sets. The work required to execute a query can be parallelized over an arbitrary number of machines, which can each work on their own slice of the data. It also has the advantage that it can be run not only locally and on-prem, but it also works with a large number of existing cloud solutions for Apache Spark, including those from AWS, Google Cloud, Azure, and Databricks. Spark has the ability to run queries over streams of data, and this enables some interesting architectures for FHIR analytics. We can leverage push APIs such as FHIR subscriptions to subscribe to changes and run transformations continuously over the data. In this example, we're persisting subscription events to Kafka and then streaming data from Kafka through the execution of a SQL on FHIR view using Pathling. This could be useful for applications that have real-time update requirements such as dashboards. Pathling has comprehensive support for querying FHIR terminology built in. This functionality automates the task of making calls out to a FHIR terminology server and joining the results back alongside your data. These functions taken together allow you to query almost any aspect of the codes that are present within your data. Pathling also features a client-side caching feature that can be memory or disk-based and can be intelligently invalidated by the terminology server through standard HTTP headers. The cache can even be shared across a cluster for distributed workloads. I mentioned earlier that Pathling takes bulk FHIR data as an input format. We're working on a couple of new features to help integrate further with the FHIR bulk data ecosystem. The first is a bulk FHIR client that can automate the task of kicking off export jobs, monitoring them, downloading the results, and importing them for analytic query. The second is an implementation of the bulk export API for the Pathling server implementation. We're also working on a proof of concept implementation of an export view server API that could execute a SQL on FHIR view and return the result. Pathling provides a library API that is available for Python, R, and JVM languages. The integration of Pathling into Python and R environments allows users to query FHIR data directly within their data science workflows, alongside the tools that they're already familiar with. The Python API works with the PySpark library, and the R API works with the Sparkly R library. Results of pathling queries can be retrieved within the pandas and native R data frame formats within these respective environments. Pathling also provides a server implementation which is distributed as a Docker image. The server currently implements import and update operations, along with extended operations that correspond to our FHIR query operations. We're planning to extend this to add the ability to execute SQL on FHIR views and also implement the bulk export API. We're still working on integrating the new SQL on FHIR view functionality into the product, and we're planning to properly release this soon. If you'd like to follow along or try this out early, there is a pull request that you can take a look at. Thanks very much for your interest.
Thank you, John. So my name is Nikolai. I'm CTO of Health Samurai. In Health Samurai, we are working on FHIR server and FHIR database. We call it FHIR backend. Simply, we may say we are FHIR server with SQL. We leverage Postgres binary JSON to give you full access over your data. So for a long time, yes, as we discussed, we do provide SQL API, but it wasn't like standardized. Yes, so it was heavily based on Postgres JSON functions. So we get together and solve this. Yeah, our primary use case, and I like this use case, so we see the nice trend that a lot of new EHR, PHR systems are written in FHIR from scratch. So we call it FHIR native or FHIR first development. Yes, and some of them are modernizing and going to be rewritten in FHIR. And we position ourselves as a backend for these guys who are going to write like next generation FHIR native systems. Okay, our implementation is in Postgres, so I hope at the end of this year we will extract it into open source Firebase 3.0 version. So, but for now it's a part of 8box. So the interesting part that we are what I call in database implementation. So we transpile view definition into SQL query. And using this SQL query, you may like expand the view definition on fly, or you may create a real database view, or you may create materialized view, or you may create unlogged table and do analytic right on your data on your FHIR server. So essentially it looks like this. So you see the view definition and the SQL code Postgres specific, which is generated from this view definition. So you can try it, so go and run DevBox. It's a free, no PHI data, but you can do any projects. Yeah, we do have a notebooks, SQL on FHIR on the first page, just follow the instructions. Or we just released a brand new view builder. For now, it's only support 8box, but we hope we will be able to connect to other engines. So the general idea that, yeah, you can visually build your views. There's a nice after completion for FHIRPass, and I will show this view builder on my next session. Let's build with a SQL on FHIR. So thank you, guys.
All right, so thank you to our panel, and thank you for your attention. Hope that was interesting and enlightening for you, and hope for you to collaborate and join the development of SQL on FHIR. So we'll open it up for QA from the audience. Did such a good job. No questions.
Yeah, that's really funny that we not yet released spec, but we already have 6 implementation. I don't know, Lloyd, do you know any
it's a record.
specification?
It's a world record.
Okay. Yeah, smart beat us. Okay.
So maybe a question from my side. What is the spec still waiting for? What's missing? Why is it not ready to release?
John, Nikolai?
Not much. I think it's pretty close. We're just doing a bit of editorial on it. We're trying to get some more eyes on it just to make sure that it reads well, it's not ambiguous anyway. We're tightening up our FHIR path subset side of things. But yeah, we think we're pretty close to being able to tag this with a version.
Yeah, I agree. So the spec is quite stable, maybe like half year since Graham joined it, and it was some distortion, but now it's quite stable for half year. Yeah, we're just working on the text, we're working on implementation, so yeah, hope end of this summer, yeah, we will publish the first version.
So would you say, I think I got from the previous talk, so we currently are doing the approach of export, doing the JSON export or using the JSON view and then using the various tools for querying that as a way to get it into a database. Would you say the spec is in a stable enough shape, or will be when it's published, to replace that? And if so, is there limitations on how complex the bundle? If you have very complex bundles, do you sense any limitations on SQL and FHIR to be able to handle that?
So I think it's down to the implementations. I mean, I can speak for my implementation. I think we're pretty ready to release. So we've got an implementation that is in production use, and we're trying to integrate that into a production-ready product. So, and we really want to release once we've got a tagged version. So that's kind of, I think it's going to happen around that same time. With respect to bundles, really we don't really operate in that context. We really operate on collections of resources. But yes, this can operate on arbitrary FHIR data, so there shouldn't be any sort of level of complexity it can't handle.
Same from us. So we released it half year ago, so some customers are already using it. So I think the spec is quite stable. So maybe some changes, but we agree that we're not gonna break anything since we do the first release. Yeah, and I think this we keep in mind this scenario bulk export, applying views, and doing analytics. So this is one of major scenarios, and if you have your use cases, please come to us, bring the use cases, so yeah, we can discuss how you can do this with the SQL and FHIR.
And Bashir has his hand up on Zoom.
Just a quick comment so regarding the bundle point, and I was not present in the presentation in the morning for how this was presented, but I just wanted to emphasize that the way view definition works is that you have one single FHIR resource, and then you apply view definition, and then you get few rows. So it's complete, like the resources are completely independent of each other. So it's actually important, and we have intentionally made that choice that the view definitions do not cross the boundaries of the resources, whether it's different resource types or even the resources from the same type. So it's completely local. One other thing that I forgot to mention in my presentation, I was rushing through it. So Chandra and Jing from Open Health Stack are actually present in DevDays, and specifically Chandra knows very well the work that we have done. So if you have questions about our implementation, please reach out to Chandra. Our implementation is a little bit different from others in the sense that we actually apply the FHIR paths on the resources, like on the input resource, and directly create like the rows and then materialize those. I think in other implementations, like I think Nikolai and at least John that we're discussing, we are explaining, the idea is to transform the view definition into like equivalent something like SQL or Spark. I just wanted to clarify that as well. Thank you.
Can I make one more comment? Because I think it's quite important. So with the standard view definition, we believe that this view definition probably will be authored by different people who are using. Yes, so what we expecting that like almost every IG will contain the set of view definition, maybe profile specific, so you just can take it and use it. Eventually, maybe we will work on a query resource. We're not yet decided, but yeah, so that's the idea.
Thanks for that. There's a question.
So the focus seems to be mostly on analytics, but I mean, at least in my mind, I have been thinking that it could also be used for measures computation as an alternative to SQL. Any thought has been given to that, or?
Yeah, so at NCQA, we're doing exactly that. We're experimenting with looking at each measure, finding the data requirements, and then generating view definitions based on data requirements, piping that to Parquet, and then reading the Parquet directly into our SQL engine to run on the slimmed down data. Yeah.
Hi. So when it comes to the array data type and when you are having those constructs getting normalized, do you see any of the limitations when it comes to how to sort this data? So in a sense, if my source system is not having the date time given, and when we are normalizing those data sets, for example, patient address, now how do we have this sorting done if we don't have the date time given, and we are normalizing those data sets like from the array constructs, majority of the complex data types? How will we decide that eventually from a normalization standpoint?
Yeah, I think it really depends on the implementation and what you're targeting, because you could target writing to a CSV file, and then your tooling would have to work on CSV files. If you have a Parquet, a lot of date and date time get mapped to different data types on the output. So that's my experience, at least, with when we converted to Parquet, I had to figure out what types to use and then how we can sort on those types we have available.
Okay, I got another one. So when it comes to the data persistency, as we start flattening this data out, right, from the retention and strategic standpoint, where do you see, like, I do have a FHIR store where I have the data being already persisted in. We are performing the extractions, flattening, and further persisting in a lakehouse conformity or a SQL store. When it comes to the retention, what is your vision or a data strategy standpoint?
Yeah, I can try to answer this question. So in our case, for example, we're trying to provide you with a store where you can directly run SQLs on top of this view definition. But there are a few other scenarios, as I told, like you may have a bulk import, ETL pipeline, then load it into a 3 bucket and run some modern stuff or into columnar databases. Or as well, we discussed that probably extend bulk export operation. So you can provide the views and we will export you flattened data. So you can directly start like running queries on this data.
I might just add to that. In our implementation, we sort of have persistence as an optional thing. So you can actually go all the way from raw FHIR data and encode it into a data frame and do a SQL on FHIR transformation and put it to some output without ever persisting anything. Or you can optionally persist it to sort of a lossless intermediate Parquet format, which you might put in a data lake, for example, and then run multiple queries off that, which is of course going to be faster because you don't have to re-deserialize all that FHIR data. So, yeah.
Thank you.
Yeah, and can I add also 2 points quickly?
Yeah, but sure.
Go ahead.
Yeah. Okay. Good. Yeah. So a few points. One is like about like sorting and aggregation and things like that. Again, that's one thing that I think explicitly has put in the spec. That, like I said, the idea is to have one resource and then generate some rows. And basically, the idea of sorting or aggregating between different rows again is kind of a scope out of the scope for the view definition. The other thing that folks briefly mentioned is that there is also this idea of baking in the view definition, applying views in the bulk export process. such that you actually get like a flat, you get a view of the data instead of getting everything from a bulk export. Now, in terms of for persistence and also the retention and things like that, obviously in some cases, like I guess like bulk export, if you get a view, then it's up to and then the resources changes, it's up to the consumer to keep the view updated. But in our system, and I think in some other systems as well, I think like John mentioned that it's possible to continuously update the flat view. So basically, the way that we do it is that we have like micro batch pipelines that run, like you can configure it, and then every hour or every day, depending on what has changed, including like if a resource has been deleted or updated or whatever, we basically recreate the corresponding rows for those resources that have been updated. So basically, your view will be synced after an hour or even continuously when we implement the subscription API support for consuming data. Thank you.
Maybe final question for me then. Are you going to make some canonical view definitions available? Like this is how the patient will be exported to?
Exactly. Yeah. That's our plan.
Cool. I guess that's it. Maybe we should call it here, Arjun.
Sorry, one point on this one. Sorry. So I think eventually what will happen is that depending on the use cases, there would be view definition resources. So like, for this particular report, so let's say for FHIR, for example, we may create like one resource per resource type, and we would say that this is all the data that is needed to generate FHIR reports. And then for some other use case, people may come and say that I need this bit of information as well for this particular report. So I think there would be several view definition, like canonical view definitions per resource type. Sorry.
Great. Well, big thank you to the panel, and don't forget about the Let's Build after this. Go. Thank you.